go for the whole screen. Okay. Okay, so we're going to go through bubble sort, and I'm going to basically go through it in a way that I'm not going to assume that you understand bubble sort at all. We're going to go right from the beginning. I know that we've already gone through it in class, but the idea is when we're revising, we're going to take it right from scratch. I'm going to show you an example of how bubble sort works, and then we're going to go and create a program which will create bubble sort and allow you to enter data in, show the data, sort the data, and then actually show it again, so you can see where things are being swapped around. Okay, so this is your sorting algorithm for COMP1. So you don't need to know any other sorting algorithms, although it's useful to be aware of them. But this is the one where you need to be able to identify the algorithm and also possibly code it. We wondered whether last year in the exam they'd ask you to use bubble sort. They didn't. That's not saying that they won't ever. So if you are able to take this in Pascal and just create a program that sorts data, you're going to be ahead of the game a little bit. Okay, so what I've done is I've created a one-dimensional array, and the way that bubble sort works is it goes up each item of the array and checks it against the item that's next to it, and then just sorts those ones and then moves all the way up the array. So what I've done is I've chosen these numbers here, put them into a random order, promptly regretted it because I realized that the 1 is all the way at the other end. So this is going to be quite a long process, and then I realized I was doing it in PowerPoint as well, so bear with me. Okay, so the first thing that we're going to do, that's a sorting hat. The first thing we're going to do is we're going to look at the first two items of the array, and we're going to work out whether they're in order. So do you reckon these ones need to be swapped? No. Okay, so because 2 obviously is less than 30. So what we can do is we then move up, and then we look at the next 2 items in the array. So we start at point 0, we move to point 1. 30 and 16, they need to be changed around. So what we do is we swap them over. And then we have to move on again. Again, we're going to need to swap those over. And then we can move on. And again, they needed to be swapped. And we move on again. 10 is quite clearly less than 30, so it needed to be swapped over. We've now got 30 and 96. And at 30 and 96, we can just ignore it and move on. Okay, 96 and 25, swap them over. Again, 96 and 3, we're going to swap it over. 96 and 1, we're going to swap over. Now at that point, what we've done is we've reached the end of the array. So the way that bubble sort works is that it goes through and it swaps all of the items until it gets to the end of the array, and then it goes all the way back to the beginning again, and it does it again, and it keeps going. So what I'm going to do is I'm going to get rid of our sorting hat, because that animation is going to have us here for an hour just moving through them. So I'm just going to quickly go through it. So 2 and 6, that's already sorted. 16 and 22, already there. 22 and 4, that's where we need to move it. 22 and 10, again, we need to move those over. 22 and 30, they're in the right order. We can move up. 30 and 25, that needs to be changed. 30 and 3 needed to be changed. 30 and 1 needs to be changed. 30 and 96 already sorted, and then we move back again. So we're using 2 different loops here. We're looping when we're swapping things over, and we're actually looping all the way around again. So 2 and 16 already there. 16 and 4, move those ones. 16 and 10. 16 and 22 are okay. 22 and 25 are okay, but then we found 3. This is where I really regretted putting 3 and 1 at the other end. You need the single animation for every single one. 25 and 1 need to be on. So 25, 30, 96, already sorted, go back again to the beginning. There you got 2 and 4, that's okay. 4 and 10, 10 and 16, 16, 22, good. Then we found the 3. And we swap them over, 22 and 1. Then 22, 25, 30, 96, already sorted. Go back again to the beginning of the array. 2 and 4, yeah, 4 and 10, 10 and 16, 16 and 3, found another one. There we go. So 3 and 16 have been swapped over, 16 and 1 need to be swapped over, but now we've got 16, 22, 25, 30 and 96, which are all in order, so we can ignore them until we get to the end of the array. We move back again to the beginning of the array again, 2 and 4, 4 and 10, there we go, 10 and 3, swap them over, 10 and 1, swap them over, 10, 16, 22, 25, 30, 96, they're all in order. So we've compared, you're still having to compare them all the way up to the end of the array. You're coming back again to the beginning, 2 and 4, 4 and 3, there we go, 4 and 3, we're nearly there. 4 and 1, 4 and 10, 16, 22, 25, 30, 96, good. And then back again, 2 and 3, it's okay, 1 and 3. Bring that over, 3 and 4, that's okay. 10, 16, 22, 25, 30, 96. Back again to the beginning. We now swap 1 and 2, and finally we have a sorted array. But that won't be the last part of that one, because what it will do is it will swap that 1 and 2. It'll then check 2, 3, 3, 4, 4, 10, 10, 16, 16, 22, 22, 25, 25, 30, 30 and 96. It'll come all the way back again and it will check all of them, because now it's found that all of them are in order and it hasn't needed to do any swaps. It will then break out of the loop. Now, obviously, me talking you through that is going to take a while. It will basically take probably less than a second for your computer to do that. So what we're going to do is we're going to set up a piece of Pascal that will allow you to enter 10 digits at random, any number, in any order. We'll output them to your page. We'll then sort them and show you where it made all the swaps. So you can actually go back through and see where your swaps have been made. And then you'll be able to then put them out, back out the page. So you need to have a simple program open. And if you want to have a look at the actual algorithm in structured English, it's there. So while the list is unsorted, for n items, so we had 10 items, so for 10 items, if the first or the nth item is more than the nth item plus 1, swap them, otherwise just move on. Okay. So this is where I want you to start off with. We're going to create a program called Bubble Sort, and because I want to clear the screen, we're going to use the CRT library file. We are going to have one array, and we're only going to use 10 just to start off with because it makes life easier for us. And I've called that data to sort. We're also going to have I, which is an integer, and menu choice. That's a char, and that allows us to actually go through our for loops, and it allows us to choose, sorry, it's a case statement, it allows us to choose what it is that we want to do. That could be, do you want to enter the data? Do you want to see it? Do you want to sort it? And do you want to see it again? So actually we only need 3 procedures for that. Okay, I can see you frantically typing. Okay, so just be aware that we've got I as an integer. What other names have we used for our stepper variables? So you might have for I equals 0, or what another one that we've used quite a lot is, no, count, yeah. Standard naming conventions are that if you're using a for loop, you either use I, which means integer, or count, because it's a counter. Some people use step, but I've not seen that one for a while. And the whole point of stepper variables, because they allow us to indicate which loop we're on, or they can point to which place in the array we're at, because it allows us to step through either the array or step through the iterations. Okay, this is the main part of the program. So this is the bit that's going to be at the bottom. So this is between your main begin and your end with the dot. We're going to have, while our menu choice does not equal Q, do you remember this from the pre-release? I completely lifted that one from the pre-release. So while you haven't quit, we're going to clear the screen, we're going to show the menu, We're going to read our line, which goes into menu choice. And then we've got a case statement, because I've got more than an if, else if. I've got 1, 2, and 3. If I enter in a 1, it reads the data. If I enter in a 2, it outputs the data. And if I enter in a 3, it's going to sort the data. It's got that read line at the end to stop it from closing. But you need to be aware that whilst we've created our main program, technically we haven't actually created any of those subroutines, because these ones that you can see here, read data, output data, sort data, and also show menu, they are user-defined subroutines, so we need to write them. So it's all very well me showing you this bit of the program, but unless you've seen the procedures, they're not going to work. What am I missing at the end of those procedure calls? So read data, output data, and sort data. What would you have seen in other procedures, other functions that happens after that call, before the semicolon? Yeah. Right. So what would you normally see? You'd normally see the parenthesis. So you see brackets after it, which allows us to pass in. The one beginning with the P that no one remembers. Oh, parameters. Parameters. Yeah, so we could technically pass in parameters to any of these, but actually because the way that we've defined them, they don't need any parameters, we just have to call them. So if you were asked in your exam to go and identify a user-defined subroutine that had no parameters, you'd be looking for a function or a procedure call which just had this, it didn't have any brackets after it. Okay, have you got that one, those all written in? Okay, so what I'm going to do is I'm going to take you through where it's called in the main program, and we're going to create those subroutines as we go. Okay, so that first one there, that first user-defined subroutine is show menu. So we need to create show menu, and that's there. It's a nice, easy one. Show menu just writes to the screen, and it's just going to say in there, please choose one of the following options. It's going to put a blank line in there, and then it's going to give us our options, and that's all it does. So a procedure doesn't return anything to the main code. That's what a function is for. And this one has no parameters because there's nothing in brackets after it. Okay, I can see you typing away. Whereabouts should this procedure actually go in your code? At the start. So we should have our procedure name, our program name, our users clauses, then our variables, and then our procedures, and then the main code goes right at the end. Okay, so all procedures and all your functions, all your user-defined should be underneath your variables at the top. That allows them to access any global variables that you declared, and then also allows the main program to access subroutines. So anything that's written before is then accessible to the code underneath it. Okay, so we'll go back to that main program there. So we've created show menu, and the next one is then read data. So if we have got our main program, we can't do anything with the data because we've created this array variable until we've actually added stuff into it. So we're just creating a quick procedure which allows you to enter that data in, and it's ever so small. It's there. So procedure is read data. It uses a for loop, and it's using that global variable I because that's a stepper. I don't want to redeclare that every time I create a for loop, unless I've got for within a for and they start to overwrite each other. Then I've got I equals 1 to 10 because I declared a static array. What do I mean by a static array? A static array, so you've got dynamic array where I don't declare how big it is, but I have a static array, so you do declare how big it is. So I've said the static array is only between 1 and 10. So if I've got array of 1 to 10, that is static, so it never changes. Whereas a dynamic one allows us to add more and more rows. Clears the screen, so that's why we've got that uses CRT. It says write enter data, and then it reads line into the data to sort. So that's our array there. Why is it reading into I rather than 1? It's counting up each line, absolutely. So it's using this I equals 1, so it'll start that first loop of 4. It's using the stepper. So it's saying go into 1 first, then go into item 2, then item 3, then item 4, all the way up to 10. Then I have 10 data items in my array, which is what I'm hoping for. Okay. So just wave when you're ready. Good. Okay, so let's go back. So we've done show menu, we've done read data, we're actually halfway there. In fact, we're more than halfway there because we've written the main program. We then want to go to output data. So now we've read it, we want to actually make sure it's there. So we're going to read it back out to the screen. We're going to do that using exactly the same thing. And actually what I did there was I took the procedure that we just created, I copied and pasted it underneath and then just changed it because it's exactly the same thing, except I haven't got a read line, I've got a write line. This is the point at which I really upset you because all I've done at this point is told you how to use an array, how to put stuff into an array, and how to then read it out. We haven't actually done any bubble sorting yet. The final one is where all the hard work actually has to come in. And this is where we have to start looking at our array. We need to start identifying how to swap things over. Okay, so we've done all of them. The last one, sort data. This is a reasonably large procedure. It's still a procedure because actually we don't need to return anything to that main program because all the main program is just getting a menu choice and playing with the global variables. Okay, there's your sort data procedure. It's going to be up for a while, don't panic, and I'm going to talk you through it. We're going to start off with some local variables. So we haven't used local variables before, we've just been using those global variables of I. But these ones, we don't want them to be overwritten by anything else. So we put them inside our parameter, and that means they're only seen within the scope of this procedure. So anything from the main code or any other procedure, they can't change holder and sorted. only within here do they exist. So we're clearing the screen, that's nice and simple. We are assigning an initial value to sorted, which is 0. And the reason I'm using sorted is I'm actually using it to show whether the whole of my array is sorted. So I'm saying, while sorted is less than 9, reassign sorted to 0. So every iteration, we're going back to 0 and checking whether that array is sorted or not. And then I've got a for loop from 1 to 9. Why am I using from 1 to 9 rather than 1 to 10? So if you're thinking about the bubble sort algorithm, it checks it, and it checks it to the next one up. Then it moves up, then it checks it to the next one up. So if I got to data for item 10, it would be looking for data item 11, which doesn't exist, and gives us an error because we're using a dynamic, sorry, not a dynamic, a static array. So there is no data item 11. So once we get to data item 9, we can check 10 because we're doing n plus 1. Actually, we don't need to then move up any further. So if 9 items are sorted, then we finish. Okay. So the next bit, once we know that we've got this while loop that will keep running until everything is sorted, we want to know, and this is the important bit about bubble sort, if data to sort I, so data to sort is our array, I, so I've been talking about n in our previous one, but we're using for I equals 1 to 9. So data sort I, if it is more than I plus 1, then we need to swap them. Now, if you're swapping data, you can't just take them and swap them over, because one is going to overwrite the other. So we need to take one, put it into a holder, move the other one, and then put it back from the holder into another one. So actually we need 3 areas where we're putting data. So you can see there, the holder takes I plus 1 and almost sort of like puts it in its pocket. Then I plus 1 becomes I. I then takes the one that you've got in your holder and puts it there. And that basically stops the clashes, because one has to overwrite the other one. Okay, so the idea is that holder allows us to swap those 2 items around without any clashes. So it takes it out of the second place, puts it away for a minute, puts item 1 into that second place, and then puts the holder back into the first place. So we're swapping them without having to overwrite them. Because if we took item 1 and overrode to item 2 now equals item 1, they're both the same. So we need to have that held in a separate place. Okay, what we're saying there, so if we find something that needs to be swapped, then swap it. Otherwise, we put sorted equals sorted plus 1. So what we're saying is that those items were sorted. And the idea is that eventually we won't have to do any of this swapping at all. We just go sorted, 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 all the way up to 9. If I get to 9, then I can break out the whole loop. If you have got that far, you've reached the end of the program. We basically created the whole thing. Okay? If you have reached the whole thing, give it a test. Add some data in, write it to your screen, see if you can get it to sort, and then write it to your screen again. I'm going to leave that up for just a minute while you finish off, and then I will show you the live code working, which is a fabulously huge risk, playing with live code online. I can see one. So, press enter again, and now put your data back on the screen and see if it's actually did sort it. Save it to your P drive. Okay, if you're happy, that's what I'm hoping to see on my screen in a minute. Let's see if it works. Oh dear. There we go. So there's mine. If I run this, what I've got is I need to enter my data, so I'm going to enter some random data there. Okay, let's print that data. So you can see that's a completely unsorted array of data. It's reasonably random. And then if I pressed 3, that should now show me all the swaps needed in order to put that into place. Okay, so that's now swapped all of that data. It got right down to 34 and 12 being swapped, then 6 and 3. And this is the point at which it all crashes. If I try and output that data, there you go. There is your sorted list. Okay, so what I'm going to do is I'm just going to pop this back onto PowerPoint and show you that slide again. Is that one? No. There we go. There's your algorithm. So the idea with bubble sort, we're going all the way through here, continually running that loop until everything's sorted, and then looking at every item up to the item n-1, and then swapping them over if they need to. When you get to the loop where you don't need to swap them anymore, well, that is the point at which your while loop ends, your data is sorted, you can put it back out to the screen. Okay. I'm going to end the online session, and then I will come and do a little bit of bug fixing with you.